let's get started and welcome David.
Thank you. All right. Can everybody hear me okay? I'm not sure if they, maybe a little bit. Testing. Hello? Well, we'll try this out. Okay, so my name is David Holton, and I'm going to be talking to you about a few different techniques through the service that we put together as part of the Turcon organization that I'm a part of for attacking specifically the Des encryption algorithm and attacking that versus the password in order to try to, I guess, break into systems without having to guess complex passwords. So just a show of hands here, did anybody catch the talk that I gave in 2012 with Moxie Marlinspike at DEF CON? A couple people. Okay, cool. So I'm just going to do a really quick recap of the talk just because there's a little bit of background with this and the service that we provide. So in 2012, I gave this talk where we demonstrated a 100% break of MS-CHAP v2, which is a mutual authentication protocol that's used with PPTB VPNs and WPA Enterprise. And it's basically a mutual authentication protocol that allows you to use a password to authenticate to a network. This is nothing new. This protocol has been around for since the late 90s. And since the late 90s, this paper specifically came out that showed that breaking MS-CHAP v2 was just a matter of breaking a few DES operations, which is around 2 to the 57. And so it was well known for a really long time that, obviously, state actors, well-funded organizations could perform this attack, but still people use PPTB VPNs, and this was integrated into WPA Enterprise, and for some reason this kind of still gained traction as a standard. So a quick overview of what MS-CHAP v2 looks like. You basically have a client that says hello to the server sends back a server challenge, the client generates its own challenge, and it kind of mixes it together to create this challenge hash. And then you basically take your NT hash, which is just an MD4 of the user's password, and then that's used to encrypt this challenge hash and creates a response, sends it back, and that's how you verify that the client has the same password as the server. And so the stuff that's sent over the network, you can obviously see the ciphertext, and then also this known plaintext is sent across as well. So we basically have everything except for the key so we have all the pieces that we need in order to try to brute force these keys. And so up until our talk, people mostly focused on attacking the user password. So doing dictionary attacks, trying all the low-hanging fruit of easy-to-guess passwords, and then using that with the whole authentication through programs like Asleep to find a password that would work for cracking this network. And if you look at if somebody had the most complex possible password for their user password, it ends up being a lot of characters, or a very large key space to search, around 92 bits. And so we were wanting to come up with an attack that would work 100% of the time, no matter how complex your password was. So the NT hash in a lot of these cases is essentially a password equivalent. A lot of these networks will let you authenticate directly just with an NT hash. You don't have to have the user password. And so we specifically worked on trying to crack the NT hash. And so that meant cracking just the DES operations. So what they outlined in the paper was basically there's these 3 DES operations that all have the same plaintext. All of these are just encrypting the challenge hash, and all of that is the same. And the NT hash is actually 16 bytes long. So in this last one, there's only 2 bytes of an actual key that's being used for the encryption operation. So that one you can easily do with any PC out there. It's just 64,000 possibilities. These other 2 require a full DES brute force. And so that's really the issue with trying to crack this NT hash from the authentication that you capture. So we have the challenge hash, and so a naive implementation of doing this would be you would just do a brute force on both of these keys, and you would do for the first key, and then you do it for the second key, and it'd be a total of around 2 to the 57 operations that you have to do. But because we're dealing with the same plaintext in both of these cases, because both are encrypting that one challenge, you can actually combine these together and just do 2 compares after the decrypt and or the encrypt, and then so you only really have to go through the key space once, just with 2 compares. So we decided to, okay, this is a great attack. Now we just need to be able to brute force Des, and and we also wanted to let everybody be able to do this and make it, something where people can't ignore this anymore. This is something that anybody is able to do. So Moxie put together this program called ChapCrack, where you can capture a PPTB VPN authentication, run it through this tool, and it'll extract out all the known plaintext and known ciphertext, and create a token that you could submit to his website that he had up called Cloudcracker, and then within 24 hours, ideally, we would be able to send you that NT hash that we cracked. And so how easy is Des to crack these days? Back in 1999, the FF built a Des cracker with a bunch of custom ASICs, and it cost them about $250,000. And their system took around 9.2 days, worst case time, to crack a Des key. And we wanted to do this in 24 hours. And so looking at all the possible options out there, just looking at like AWS, using CPU cores to do something like this would require around 80,000 CPU cores working for 24 hours, which would cost around $125,000. With AWS P1 instances, which are their high-end GPU instances, it would take around 1,800 GPUs, and that would be around $20,000, which is still very expensive. And my background is in working with FPGAs, and so I just happened to have a bunch of FPGA hardware laying around for my company, and decided, okay, well, we can take all this hardware that's just going end of life right now, put it up online, and crack Des with this. And with basically one 4U system, we can crack Des in around 24 hours. And so let's just put that online, provide the service, and we'll just charge like $20 to do this, because we didn't want everybody just flooding the system with requests. And then that ended up moving into my basement. So this is my little room in my basement with the server in it. And so this is basically the guts behind Cloudcracker and our new service called crack.sh. So then, of course, this is vulnerable. Everybody can crack Des now. So then, of course, everybody rushed to fix everything, right? Right? So we specifically called out iPredator in our talk in 2012. And I went and looked at their webpage recently, and they just put a little warning on there like, oh, by the way, PPTP is kind of insecure, so you may want to use it. We still, of course, support it, so everybody still connect with it, but just a little warning. And this is pretty much most of the VPN providers out there just put up a little warning and said, oh, just keep using it, it's fine. And then also with WP Enterprise, people just kind of said, oh, well, of course everybody does strong certificate checking in the enterprise, so that's not really an issue either. So it just kind of got dismissed out of hand. And so we started running the service, and we were doing quite a few jobs, and we started noticing some very interesting jobs come in. Like this one, for example, where it's plaintext 11223344. That doesn't look very random to me. Does anybody have a guess of what that might be? Anybody? Okay. And then this one where both of the ciphertexts are the same value. So so with that, it seems like they're not doing MS-CHAP v2. They're just trying to crack a Des key. And then I started seeing some articles, people actually using the service for cracking WP Enterprise. And the one thing that caught my eye related to this, where we see the 11223344, is that the default challenge that is sent out with the SMB capture module with Metasploit is 11223344, and there are articles coming out saying that you can basically use the service to crack Samba authentication, like Landman and NTLM-v1 authentication with Windows. So people were obviously using the system for more than just MS-CHAP v2. And then one day, traffic just kind of dropped off. I stopped getting jobs to my system from Cloudcracker, and Cloudcracker.com mysteriously disappeared. I have no idea what happened. And I messaged Moxie and everything, and he never replied to anything. So people were emailing me saying, hey, they needed to run jobs on it. And so I ended up creating this new site called crack.sh, which is run under the Torcon organization. And it's basically just specifically dedicated to Des cracking. And it works pretty much the same. It takes all the same tokens that that Cloudcracker used to do for MS Chat v2. So while I was going through this whole process of kind of reinventing the service, I did some research and I was trying to figure out what people are actually using the service for, so we could expand out the different things that we support. and what other features they might want to add in. And the real goal of this whole project from the beginning was, how can we kill Des once and for all? You know, it should have been killed back in 1999 when it was demonstrated that people could break this easily. And now, you know, almost 18 years later, it's still out there pretty prevalently. So how can we make sure people finally switch away from this? So looked into the Windows authentication a little bit more, and it's pretty much, I think that Windows authentication technically uses MS Chat v1, which is very similar to MS Chat v2, but the challenge is provided entirely by the server instead of hashing it with the server and the client challenge. And so it actually makes it a bit easier, and that's why you can actually provide your own challenge to the clients that are connecting of the 112233. So so there are articles online on how to use this, and then obviously people were using the SMB capture module for this. And basically the values spit out from the SMB capture module you can plug directly into crack.sh, and then within 24 hours it'll spit out the NT hash that you can use to authenticate to the system. And then also same with, has anybody here used Responder? Responder is another popular one that basically kind of replies to any sort of NetBIOS resolution requests, and then you connect to this fake server, and they can do downgrade attacks and things like that. So if you tell it to downgrade, you can get clients to connect and try to negotiate LANman and NTLM-v1, and they'll actually just kind of automatically start doing negotiation with the current user that's logged in, so you can start grabbing their credentials. And then those values can be plugged directly into crack.sh, and then you can get the NT hash for those users. So also looked into WP Enterprise, and back when we originally did this research, people were using free radius WPE, which is kind of a patch for free radius that just spits out the challenge and response parameters. But now there's this other program called HostAPD WPE, which is a lot more popular, and so we're going to be doing a demo actually at DEF CON with this, and have some more details about what clients actually do strong certificate checking there, and also at our talk at SHA in a couple weeks. So so now we ended up adding in the support for basically taking these net NTLM hashes that you can normally feed to John the Ripper. And so now you can put those directly into the system, and then that'll crack the NT hash for WP Enterprise. And then once you have this NT hash, if you want to actually connect to the network, you can use WPA supplicant, or there's various clients that'll let you use the direct NT hash instead of the password to connect to the WPA network. Another thing that we saw right after our talk in 2012 was Karsten Knoll gave this talk on rooting SIM cards, basically sending over-the-air updates to SIM cards. And a lot of these are secured with single DES. I think a lot of the newer ones use triple DES. But he actually basically used, I'm not entirely sure if he used our service or not, but his theoretical attack called for having something that could crack DES in order to crack these over-the-air update keys. So you can send remote updates to SIM cards to listen in on their phone calls and read out their contact book. And and there's a full Java virtual machine in there that you can rewrite and put in backdoors and stuff like that. So and then also, if you guys watched Mr. Robot, this was on one of the episodes, so that was kind of cool. And then we also wanted to provide just a general purpose interface for people to be able to crack DES no matter what sort of protocol they're looking at. And so we put together an API, and we wanted to have some really simple rules. So we basically just say you can specify a ciphertext and a plain text and a mask for the compare, and you can say whether you're doing an encryption or decryption. And then as long as there are, I think we limit it to you can only have like 24 0 bits in your mask, and so as long as you're within that, then we'll send you a list of all the possible keys that match that, and then you can use software to quickly go through all the candidate keys if you're wanting to compute some checksums or do some other sort of thing to verify if you found the right key or not. And so we put up this whole interface, and then we wanted to figure out kind of an application for this. And so for a while, I had some friends that looked at Kerberos 5. And for a while, they were saying, oh, yeah, there's still people out there that are using Kerberos 5 with the DES option. And so I thought I'd just take a look at it. And it had been known for a while that you can do downgrade attacks on Kerberos. And so that basically kind of affects like the whole, all the ticket issuing and stuff like that. And there's plenty of known plaintext throughout all of the communication that goes across. I'll be getting into in a second. So what I did was I created an ettercap filter that basically just modifies the supported encryption types to all be DES CBC CRC. So like over here, you can actually just see DES CBC CRC. There's like 6 times that it says, oh, we support DES. And then this actually works for most clients that do support DES. So it forces them to use that. And then because everything's encoded in ASN1, there's lots of static fields in there that are pretty much always there just because that's just part of the protocol. And so there's plenty of known plaintext that we can use to derive enough information to crack the key. And because CBC just relies on, with the blockchaining, it just relies on the ciphertext of the previous block, you can basically take any block within that and just take the ciphertext of the previous block and then your known plaintext and all of that, and then be able to crack any individual block within the chain. So it basically makes it fairly easy for us to crack as long as you can find some plaintext. And so we put together a little tool that you just feed it a PCAP file of a Kerberos authentication after you do the downgrade attack, or if they, for some reason, only use DES in this, you don't have to do that. And then it'll actually pull out all of the known plaintext, create submission tokens, and you can feed that into Cloudcracker or to crack.sh, and then we'll send you the actual DES key that they're using for the authentication. So the only issue with this is that I have no idea what to do with that DES key now. I've cracked a bunch of these, but there needs to be software written to actually authenticate to hosts or support built into Impacket or Kerberos or some of these other tools out there to actually make use of this. But at least everybody should know this is easy to break those keys right now. And in my day job, I actually just double checked the supported encryption types for a network, and we totally support DES. And so I'm sure a lot of environments out there that have any sort of legacy hardware on the network will probably support it as well. So yeah, then you can pop into the website for these because it takes a little bit longer time. It's $30 to crack a key, but usually finishes within 24 hours. So then after having the site up for a while, I started getting these weird emails asking if I can crack Des Crypt. Does anybody remember Des Crypt from a long time ago, like with old Unix systems and stuff like that? It's 25 rounds of Des. And I think the max number of characters you can type in is like 8, and it just truncates the rest. Kind of similar to the talk that was going on before the break. So this algorithm was originally designed so that a PDP-11 would take more than 1 second to compute the hash. So they were like, oh, this will prevent everybody from cracking this. And so you think that like something like this, where I think that they started using this in the early 70s, mid 70s, nobody would be using this anymore, right? So it turns out that QNX, they support either Des Crypt, the 25-round version, or their own proprietary one that's fully reversible. So Des Crypt is actually their most secure version of a password hash that you can use. And And there's, at least from this press release from over 2 years ago, there's over 50 million vehicles with QNX, according to QNX. This password hash listed in here is actually out of the Charlie Miller and Chris Valasek paper on when they hacked the Jeeps. And so I just started Googling around, trying to find random, Des Crypt passwords. I found this other presentation online. There's all these forums where people just post random hashes, and there's actually quite a few out there. I was very surprised. And so I was like, okay, this is great. I can code up something that'll try every possible password for this, because it's definitely within the realm of brute forcing, and we can just add that to the service, and it'll be great. All these will just be totally broken. So if you look at all the possible typable characters, it takes around 3 days to brute force this with the system that I had. So I'm like, okay, I got this one from the Charlie Miller and Chris Valasek paper. I'm going to crack that one. So I throw it in there, and I crack it. And it must be super secure, right? All these must be super secure, I'm sure. And so I even got this one from Carl Kosher that he reverse engineered some, I think it's all the OnStar systems out there. And he got the shadow file from it. And so that one is just root. Root. The one in the Jeep hacking paper is DT Donkey. The one in this other presentation I found is just 8 random characters. And so, if anybody here has any of these old Des Crypt hashes that you haven't been able to crack with just normal John the Ripper, please let me know, because I'd really like to find a good use for this service. But but instead, I've wasted 3 days of a ridiculously expensive FPGA system to crack really simple passwords. So anyway. So if you have any ideas of things that still use Des, we have a simple API that you can use to create your own tokens to submit to the system, and you can verify your implementation. There's it's all in Python, so it's easy to understand and create your own tokens. And then you just drop it in, and you get a nice email with a text file with all the keys that match the criteria that you gave it. So, after we put this together, it still, it seemed like there still wasn't much being done to phase a lot of these things out and fix the problem. And it seemed to us the biggest problem with the service was that we still, we have to charge money for it. And really, that's just a factor of rate limiting. We could totally offer this for free, but we don't want, a backlog of, a couple years, because it does take, a full day to crack these. And power costs money. It's expensive running, running a system that draws a couple kilowatts. It normally costs a couple $100,000. So we asked ourselves the question: what if we could make this free? How can we make the service free for everybody to use, and still not have backlogs of a year or two? So, especially after seeing the stuff people are doing with cracking Windows authentication, started looking into creating rainbow tables for Des. And this is a pretty large key space. If anybody's familiar with the different rainbow tables out there, there's the off-crack table that does a 95 to the power of 8. They charge money for it, but it's 2 terabytes, 99% of success rate. I have no idea how long it takes to crack a key with it, but it's pretty decent size. The table that we wanted to build was around 10 times bigger than that one, because it's for 2 to the 56 instead of around 2 to the 52 and a half. And we want to build this with 99% success rate, because we want to basically make it so that if our table can't find the key, then we'll just have it brute force it, and then save the result of it. So we can kind of, over time, be able to, kind of fill in the gaps that the table isn't able to fill. And we wanted to make it so the speed of cracking was fast enough that it wouldn't take a year if we got a backlog of jobs. So looking at the hardware that we wanted to use for this, the Nvme drives that are out nowadays are actually really amazing. Has anybody looked at the new Nvme drives? A couple people. So as far as doing rainbow tables, really a big factor is your lookup speed. And a lot of the Nvme drives nowadays, especially if you're doing really short reads, can get up to like 1 million IOPS per second. And they only advertise about 500,000, but especially with really short reads, they're really ridiculous. And and for really fast storage like this, 6 terabytes is somewhere around, maybe $800-900 per terabyte. And so, for around $5,000, we could have something that's pretty screaming fast. And then we were able to borrow some FPGAs for the system. And it seemed like 12 would be a reasonable number to borrow. And then we also borrowed another server from the server room. I don't think they'll miss it. And so with those parameters, we came up with some table parameters, roughly 500,000 links in a chain, and then around a quarter of a trillion chains per table, and each table would be about 2 terabytes, and 3 of those to fill up the 6 terabytes. And that would give us around like less than 3 seconds, and I think around like 98% or something like that. So pretty close and super fast. So we borrowed some hardware, and we just happened to have some hardware that wasn't sold yet. So we're like, oh, we'll just burn in this hardware, see if it works. And so I filled up a system with 48 FPGAs that we normally sell for, I think, like $4,000 or $5,000 a piece or something like that. And get her done. But then there were some issues. We, especially cramming that many in there were some overheating problems. I don't think that the previous engineers had ever run something this intense on these FPGAs. Another issue with hardware, especially with stuff like this, is that power supplies aren't normally designed to go from, say, like a couple amps up to 50 or 60 amps, like that. And so we ended up having FPGAs just dropping out, just even just like loading the FPGA or starting off a couple jobs. So we had to put in a bunch of delays in it, so it slowly phased in, which cores were being activated, so it would be a nice smooth transition with the stepping. And then even on top of that, like we ended up overcurrenting the supplies. I think they had like 40 amp supplies on them, and we were drawing a bit more than that. So so we had some hardware issues, but it took a while to get over that. We got over it, and so now we're okay. Let's get going. We got this fixed, and spent weeks generating tables. And then I don't know if anybody here has generated rainbow tables before, but we spent weeks generating them, and then went to sort them, and then there was just like a really high collision rate. And so that basically meant that the tables we generated over the few weeks were basically unusable. So learned some lessons, and then came up with some new parameters. And so we basically just had to essentially make the attack a little slower. And so the trade-off is basically that now we have less chains per table, which means that we have more tables, so then it requires that much more time to actually compute your chains forward and stuff like that for doing the real-time phase. But one advantage is that because we have a better collision rate, we have a lot better coverage. So now we should be a lot closer to 100%. So then we try again. And the only problem is that now some of the borrowed hardware had to go out to customers. So now we're dealing with a lot less hardware. And otherwise good to go. Fast forward a few weeks, but that was actually a week ago. So long story short, we were supposed to have this fully done before now, but right now we're only about halfway there. But it is up. So the cracking system's up. This is another system that I borrowed. And we put in some nice packing foam to redirect air on the FPGAs. These are all the Nvme drives. And so system's up and running. And we only have 50% of the tables generated right now. But with rainbow tables, that actually means we're over 90%. We're at 92% right now, which is actually pretty decent. And and it's free, which is great, right? And we're getting closer every day. And actually, we'll be at 99.5% next week. So pretty much, yeah, right after I get back from DEF CON, we'll be up to close to 100%. And this takes, because we're cracking 2 keys, it takes around 24 seconds or something like that per job. So do we have time for a quick demo? Oh yeah, we got plenty of time. So I just wanted to demo using Responder to crack a net NTLM hash to an NT hash and then see what we can do with that. So, oh yeah, let me get up my notes real quick. I always mess up demos if I don't have my notes. All right. Okay. So, what we have here is Kali Linux and Windows 7. So I'm just going to, both these are on the same internal network. I'm just going to fire up Responder with the LAN-man downgrade option. So that's fired up. And now, I mean, obviously in a production environment, we're going to be browsing to real shares. But so I just put in blah, responds to it, and now I have an NTLM v1 hash right here. And so normally we would take something like this and put it into John the Ripper, but we're going to take that NTLM hash. And another thing to note, too, is that in Responder, I set the challenge to the 11223344, and that's important for the rainbow table to work, because it's only built for that specific plain text. So now, now that I have that hash, I'm going to switch over to crack.sh. And as long as nobody killed my internet connection here, I'm going to put NT hash. So now it just asks for an email. There's no payment or anything. I put in my email address. Submit. And pray to the demo gods. Maybe. Oh, waiting. I'll try submitting one more time. Oh, that's working. Somebody just decided this would be a great time to DDoS crack.sh, right? All right. Well, yeah, I mean, this was put together basically last night around 3 a.m. So, that'll definitely be going up soon. Well, so worst case, I have a bunch of ones in my trash here. Let's see here. Oh, what's the last one that I did here? Okay. So this is you'll basically get an email kind of like this with the NT hash. So now we can go over to here. And so now with the NT hash, let's do the SMB client. So let me paste our hash. And now, oh, okay, so we're on the system. That's pretty cool. And then let me fire Metasploit. Or if you have like a PS exec or SMB exec or something like that, I'm just going to create a shell over to it just so we can see that. So we're going to do a, oh, oops. Oh, wait, interpreter, sorry. That's right. All right, and then, so then we're going to have it call back to us. And set our Samba password, which is going to be our hash. User, and now, okay, so now we're connected, and fire up a shell. Oops. And we're system. So now, yeah, you can do whatever you want on the system using the NT hash. So, and there's tons of other tools out there for using NT hashes to exploit systems and stuff. So, so I mean that's the basic demo. Let's see if this ended up actually going through. Oh yeah, so yeah, when it actually goes through, then it'll give you a little page where you can check your status, and then it'll send you an email. And then we also have a API that we're going to be releasing here at DEF CON. We're going to be in the demo labs room. If you want to find us over there, we'll be demoing a few different things. And so we're setting up a REST interface. We'll have to figure out a way to prevent people from abusing that too. But for now, we actually had somebody contact us recently, and they put together an airbot check plugin, so you can submit stuff through Slack or IRC or whatever. I don't know what you use chatbots for. And then we're also going to possibly integrate with like host APD, WPE, so it can just automatically, crack the hashes, or we could even integrate directly with responders. So, as it finds those, and it automatically just reverses them to NT hashes and displays that. So there's lots of fun that we could do with this. And so if anybody's interested in writing some stuff using our API, let me know, and I'll give you some more info on it. And then, of course, there's lots of people that have kind of helped out with all the related research, so I just thought I'd include them in there. And otherwise, help me kill legacy crypto. I'm calling on everyone here. If you have any ideas or want to help out with this at all, let me know. And if you want to run any free jobs, just email me. I mean, it really is just for rate limiting the system. So shoot me an email if you have any ideas. Everything's on GitHub, crack.sh. And I also help run TourCon, which is going on next month. The main conference is September 1st through the 3rd. So I hope to see some of you there. And then we also throw a really amazing event called Tour Camp that's happening next year. And it's the US Hacker Camp. We're out on a beautiful island up in the Northwest. And so that's always a lot of fun. Thank you very much. Any questions? Oh.
Anything against triple deaths, aside from being a little slow and untold deaths?
Sorry, what's that?
We just
Oh, yeah. Triple
Okay.
Des?
So would you consider triple Des legacy that should be killed with fire?
Yeah, I mean, I think most people would consider it legacy, but yeah, it's nowhere near. I mean, it's not something that I can crack with the hardware that I have laying around at my company. I'm sure, with enough storage and dedicated hardware, I'm sure governments and well-funded organizations could do that. But yeah, it's definitely well out of my parameters of like a real attack is something you could do within 24 hours or within seconds. So yeah.
So how long did it take to compute the table, and any idea how long it would take to do that on F1?
So I probably should have included some F1 numbers. So with the tables, I mean, it's kind of it's been a hodgepodge of like generating tables on like various systems around the office. I think the total amount of time for each table just generating is around 48 hours with like 12 FPGAs, and then we have to do 12 of those. And so I don't know. It depends on how many FPGAs you have and stuff like that. And I'd have to work out the math on how equivalent that is to the I think it's like the V9Ps that F1 has. Yeah, I mean, I imagine that it wouldn't take that long to generate something like that on F1. I would have done it on F1, except I was mostly concerned about the speed of the drives for doing the real-time attack and stuff like that. And so I guess I need to just see how fast the drives are. If we could be doing close to like 1 million IOPS per second with something like that. And then another consideration too is that I looked at switching over this whole service to F1, and just in F1 credits, it would cost more than the $20 a month or whatever that we're charging, or $20 per key that we're charging. And then especially as a free service, and that's something that we have to pay, And so it's a lot easier when we can just kind of borrow hardware and, but yeah. Yeah. I mean, it probably would have worked pretty well for generating the tables just as far as scaling up. And especially with the sorting process takes a lot of time too. But then, yeah, once you have the tables, then it's a matter of, getting the 6 terabytes out of the EC2 or the storage. And so, yeah, I don't know. It seemed, at least for me, it was easier to do it on our hardware. But yeah, it seems like it probably wouldn't take that long on F1 hardware. It mostly depends on how much money you have to spend.
Are you looking to make those tables available to others?
Yeah, sure. Yeah, I need to clean up all the code and stuff like that and figure out a good way of distributing 6 terabytes. But yeah, I'll definitely, if there's people that are willing to torrent it or whatever, then yeah, I'll figure out a way to get it out there. And I have no idea how long it would take.
DEF CON Data Duplication Village to help you out.
Oh, yeah, there we go. Yeah. Yeah, somebody will bring some hard drives next time or something. And yeah, there still needs to be we still need to write support for running on GPUs or CPUs or other sorts of hardware too. So right now it's very specific for FPGAs and Nvme drives and all that. Any other questions? Oh, go ahead.
Rough idea of how well the rainbow tables would perform on rotating memory?
Just on normal like magnetic storage, or
Yeah, if you copy those things onto spinning regular spinning commercial hard drives.
Yeah. I don't know what modern like 7200 RPM drives are. I thought it's in like the tens of thousands of IOPS or something like that. So yeah, if you're running on a CPU, it'd probably be totally fine because everything's going to be a lot slower anyway. But if you're willing to wait, hours or days, then it probably doesn't matter what storage you're keeping it on.
Which versions of Windows still support DES out of the gate?
Oh, for like Kerberos or for like the LAN man?
You showed the downgrade attack. Which versions of Windows can I pull it off with, and which ones do I have to pray for a bad sysadmin?
Well, so by default, I think it's probably like Windows 2000 and maybe Windows 2003, or at least like pre-Service Pack or and XP and stuff like that. But yeah, it's definitely fixed in Vista and newer. But yeah, like for our environment, we have Windows 7 and Windows 10 and stuff like that on our corporate network, and all of them only support RC4 and DES, just because we have tons of other systems out there. And I guess also there's a number of systems like for handling like all of your IT account creation and password maintenance and stuff like that they basically reverse engineered all these protocols, so they only support the really old ones like RC4 and DES to be able to do all that stuff on the network. So yeah, I would really check your supported encryption types on your network to make sure, because just because you're running Windows 10 doesn't mean that you don't have DES as an option. Just
MIT. Do you mind a Unix MIT Kerberos question?
Okay.
Okay. So, say you've upgraded your host keys and your user keys to triple DES or AES. At least historically, the Kerberos master database password has you initially set up DES, and it's been difficult to change. But I think they said it's okay because it's not really exposed.
Huh.
And any ideas about that?
Yeah,
we've upgraded ours.
When I was setting up this whole thing to the whole attack environment and stuff, I set up just with like the standard Kerb 5 that comes with Ubuntu, and it wouldn't let me have my master key be single DES, I think. And so I don't know how legacy you have to go back before they actually let you do that, but yeah, I'm honestly not that familiar with Kerberos, so just yeah. But yeah, I'm sure a lot of the older systems where DES was a lot more prevalent, it'd be pretty difficult to switch from that. All right, any other questions or? All right, well, I'll be around after the talk, so yeah, just come on up if you have any more questions. Thanks a lot, appreciate it.